Hello, in this video I will show you how to create durability measurement system on our model. So, as I said that we have made everything, now it's time to create a FEM simulation of train stop buffer. So, we will start from creating new project and rename this to train stop buffer FEM. Now we must import our shape. Okay, so this part is in format which is not understandable to shape formatter. So firstly I must switch to part design in which I'm actually and make from this compound. So after click on the compound I can see the wall shape is selected. So it's great. Now I'm switching to FEM workbench. And in this workbench, I'm creating an analysis container. And into analysis container is solver. After clicking solver, you can change the type of analysis. But now you should close. Next, we will determine the type of material using in this shape. So clicking material icon and select from list. Here is a lot of materials like graphite, like plastic and other types like steel, common steel, ceramo, steel, and stainless steel, also titanium and wood. We will use stainless steel for my personal purpose, but also you can use another type of material, but keep in mind that every material has its own property, tough word to say, and this property determines how material will be react. So for example, the ABS generic is more plastic than iron or steel. So keep this in mind. So I'm using, as I said, CRMO16 steel. Click OK. Now it's time to select sufficient mesh. So clicking compound, and now we see two icons of meshes. I switch to Gmesh, and this is really important to select first order, not second order. When you select second order, your animation won't pass due to the fact how much density it is. Second order is more accurate than first order, so we will use here first order. Click apply. Everything has passed and click OK. You can hide mesh. Now it's time to determine the fixed force. This is a force which holds element not allowing to movement. So select fixed tool, constraint, click add, and add this force to its surface by clicking on. After when you add to every, you should click OK, and then we will determine the force working against our construction. So I'm clicking the force, I'm clicking again in add, and I'm selecting the surface which will be working. So this is surface and this is the surface. As you see, the arrows are in reverse direction that should be, so I click reverse icon. Next, OK. Now, oh no, we must determine on also one more property. This is the load. This is the energy working against the construction. For us, this will be 100 newtons. So it is less than train, but I think the computation amount needed for such simulation is not sufficient to this personal usage. So we will stay with this. Okay. Next, we should click into solver and click onto icon called as solver job control. Next, we'll see working directory, analysis type. After select, we will stay with default static. Click to write in P file. After this will finish, click in run calculate X and wait when pass. When everything will be okay, we can check our animation. As you see, we are seeing the bar, but simulating the force and the material disposition. Close, and here is a result display options. You can select this stress cascades and etc. to get how stress is conducted in this material. So this is the stress. I don't want to be enumerating over everything, but I can show the minimum. So for example, displacement. This is the displacement. As you see, it works differently, and we can go now to another, which is results. And these results occur mass because some happen with our mesh. So maybe I will hide now, already is hidden. So we'll try to make something more with, with this animation. Switch to task and see displacement. As you see occurs, we can even show the result of our action. So here definitely something worked wrong. But nonetheless, displacement is shown on a datagram. So for us, this is sufficient because this is a result of calculation. This is more graphical one, but as you see, the integrity of material isn't great. There maybe some mistakes happen. I don't know which. You can write this in comment. I'm I will change this when something has been wrong made. So close, and as you see, our construction is totally fine. So thank you for watching and see you soon in next video. One more information for you, because this video was the last one from our series of making this solution. I'm here to advertise for you that in future I will create for you another set of series which will be touching the more sophisticated models than this is. So I hope you have a lot of joy and see you soon in next video.